Hi, hello, welcome back to the course on mechanical measurements. I am Nilambika N from the Department of Collegiate and Technical Education. I'll be discussing a unit 2, that is transducers and strain gauges. This is a session number 4. So before we let into the session 4, we shall summarize the things which we have learnt in the session 3. So we saw the first thing we have learnt in session 3 is voltage and current generating analog transducer and its types. So what is this voltage and current generating analog transducer? These are the transducers where the input parameter is converted into the electrical signals. Okay, we saw some two types there. Number one is self-generating analog transducer and the second one is variable generating analog transducers. So next one we saw the self-generating analog transducer and its types. So in the self-generating analog transducer are those the input parameter is converted into the continuous signal, and for this conversion it does not require any external power source. For example, we saw piezoelectric crystals. There the force was applied and the applied force is converted into the voltage. To this conversion it doesn't need any external power source. So we saw some types of self-generating analog transducer. Those were single coil transducer, 2-coil inductive transducer, electromotor transducer, electrodynamic motor for rotary motion transducer. Then we saw eddy current transducer. Next we saw the concept of self-generating analog transducer. Here with the example of single coil, using magnet and a single coil, we understood the concept of self-generating analog transducer. Next we saw the variable and current generating analog transducer. These are the types of transducers in which the input variation is converted into the variation in the capacitance or variation in the resistance or variation in the inductance, which in turn it is converted into the voltage. For this conversion we were used the external power source. So the difference between the self-generating and the variable generating analog transducer is, in self-generating we does not require any external power source, but in variable we are using external power source for the conversion of one signal to the another. So we saw some types of variable and current generating analog transducer. Those are variable inductance transducer, air gap inductance type transducer, magnetostrictive transducer and LVDT transducer. So these were the 4 types of variable and current generating analog transducers. So next we saw the concept of variable and current generating analog transducer by using a 2-coil, so which were tapped at the center, which is connected to the non-magnetic material. By using that we learned the concept of variable and current generating analog transducer. The next we saw the sample questions from that session. The next we concluded with the session with the MCQs. Now today we are going to discuss some of the topics in this session. Are the number 1, we shall see what is piezoelectric effect. What does it mean? So we are going to go through the piezoelectric effect. Next we shall see some of the materials of piezoelectric materials. Next we are going to see some desirable properties of piezoelectric materials. What do we expect from the piezoelectric materials? Some desirable properties. So we shall see. The next is we shall see the piezoelectric transducer. What is piezoelectric transducer? How it works? The next we shall see some of the advantages and disadvantages of piezoelectric transducer. Next we shall see some sample questions from this session that might be asked in the end examination. Then we shall summarize whatever we will be going to learn in this session. So last shall conclude with the MCQs. I'll be giving some multiple choice questions to you. You need to write down the answer. So let's start with the first topic in this session is piezoelectric effect. So before going to the topic, I would like to say there are some materials. So for those materials, whenever a force is applied to the material, it is going to convert into the voltage. So conversely, if the voltage is applied to the same material, we are seeing the change in the dimensions of that material. This effect we call it as a piezoelectric effect. Piezoelectric effect is nothing but I am applying a force on the material. It is going to convert into the voltage, and if the voltage is applied to these materials, piezoelectric materials, I am seeing there will be a change in the dimensions. This effect I call it as a piezoelectric effect. As said, when a certain materials are applied to the mechanical force, a voltage is produced. So conversely, when these materials are applied with voltage, there is change in the dimensions. This effect we call it as a piezoelectric effect. Here there is a piezoelectric material between the two metal plates. So that is connected to the two plates are connected to the output voltage. Whenever a force is applied to these materials, the force is proportional to the output voltage produced. I hope you are clear with this topic. We'll go through some of materials of piezoelectric materials. So there are two types of piezoelectric materials. One is natural materials, another is synthetic materials. So natural piezoelectric materials are like quartz, tourmaline, group minerals, and synthetic materials, they are more sensitive than the natural materials. So synthetic materials are like Rochelle salt, barium titanate. So if you see the quartz, so all the materials cannot give all the characteristics. So one material will give one of the characteristics. If you take a quartz, commonly used piezoelectric material is quartz. So maximum we are using the quartz itself. So because the quartz is a more stable material. So because of this character, we are using quartz more. Next one is Rochelle salt. Rochelle salt will give it is a synthetic material, but it gives high output. If you take the barium titanate, we can easily change the shape and size of barium titanate. So this is a character of barium titanate. It is a synthetic material. So another material is berlinite, sucrose. The next is topaz. Then lead titanate. So next material is tourmaline group minerals, silk, tendon, langasite, gallium orthophosphate, potassium niobate, lithium niobate, sodium tungstate. So these were some of the materials of piezoelectric materials. Next we shall see some of the desirable properties of the piezoelectric material. So piezoelectric materials it has stability. So these materials are more stable compared to the other. As I said, quartz is the most stable material. So and the next is it gives high output. So compared to the other materials, these piezoelectric materials give high output. And the next is they are insensitive to temperature extremes. Temperature doesn't affect the output. The next one is insensitive to humidity. Humidity is nothing but a moisture content in the air. So these are insensitive to the moisture content, because the moisture content also affect the piezoelectric material for the output. Next is the one of the best desirable property of the piezoelectric material is the ability to be formed into any desired shape. So we can form these materials into whatever shape we want. Okay, these were some of the properties we saw. The stability, it is a stable, almost maximum stable. Materials are stable. It has high output. They are insensitive to temperature. They are insensitive to humidity. And the best character property we saw is the ability which can be formed into any desired shape. The next we shall see what is piezoelectric transducer. So piezoelectric transducer is a one which uses piezoelectric effect to measure the changes in the acceleration, pressure, strain or a force. So this transducers, as I explained the piezoelectric effect. So this transducer, it is a device which uses piezoelectric effect. So by using this piezoelectric effect, it measures the changes in the acceleration, pressure or a force. So if you see this diagram, we are placing a piezoelectric quartz crystal between these two electrodes. So whenever a force is applied on this piezoelectric crystal, it is converted into the voltage. This voltage is proportional to the force applied on it. Right? When a force is applied on the plate, a stress will be produced in the crystal and a corresponding deformation is formed. Hence, the voltage is proportional to the force is induced across the plate. Now, the voltage E is equal to GPT. So, where the T is the thickness of the crystal, P is the impressed pressure, G is a voltage sensitivity. So, this is all about piezoelectric transducer. Next, we shall see the advantages of piezoelectric transducer. The first advantage is it has high stability. So we saw this character in desirable property as well. So it has one of the best advantages is it has high stability. It can withstand, it is stable at all conditions. And the second is the piezoelectrical transducer we use, it is of small size so that it can be easily handled. The next is high frequency response. For parameter changing rapidly can be, the output will be given very instant. So it is having high frequency response. If there is sudden change in the input, then we are going to get the sudden change in the output. So output is high. It has high frequency response. The next one is rigid construction. Means this transducer is made strong to withstand rough handling. Even if you handle roughly, it doesn't affect to the transducer. So it is made strong. The next advantage is it is suited to dynamic measurements. So if you see, there is a pressure variation in the IC engine. So instantly for 1 minute, 2 minutes, there will be always change in the pressure. For this we need to get the output instantly. So this is used for the dynamic measurements. Change in the, if there is change in the output, we are getting output. For static conditions we cannot use. So we are using, it is well suited for dynamic measurements. The next we shall see the disadvantages of piezoelectric transducer. The first disadvantages is the output is affected by change in temperature. If there is any change in the temperature, the output will be affected. The second one is, as already said, it is suited for dynamic measurements. I can say that it cannot be used to measure the static conditions. So it is suited for dynamic measurements only. It cannot be suited for static conditions. So this is one of the disadvantages of piezoelectric transducer. Another one is the output is quite low. It's not always low, but sometimes it is quite low. These are some of the disadvantages of piezoelectric transducer. Once again, I like to say it has high stability, so it is stable at all conditions. It is of smaller size, so we can handle it easily. And the third is it has high frequency response, so if any change in the input parameter, we are getting instantly output. So it is of rigid construction. It is made strongly so that it can be used for rough handling, and it is suited for dynamic measurements. That means, I said, if there is a pressure changes in the IC engine, in that condition we need to get instant result. So changes, if your input is always changing, we use dynamic measurements. It is suited for dynamic measurements. So another we saw the disadvantages is, the first one, the output is affected by change in pressure. If there is change in pressure, the output is definitely, it is going to affect. And the second is, it, as already said, it is suited for dynamic, means it cannot be suited for static conditions. And the last one is, we said the output is quite low. Okay. We shall see some of the sample questions from this session that might be asked in an examination. One is, what is piezoelectric effect, and list piezoelectric materials. Second one is, explain piezoelectric transducer with sketch. They may be asked, list advantages and disadvantages of piezoelectric transducer. So we shall summarize what all we have learnt in this session. The first one, we saw piezoelectric effect. So what is this piezoelectric effect? Already said, there are certain materials, when a force is applied on those materials, it is going to convert into the voltage. Conversely, when the voltage is applied to the materials, so we can see change in the deformation, change in the dimensions, change in the parameter of those crystals. So this effect we call it as a piezoelectric effect. The next we saw some of the piezoelectric materials like quartz. So we saw two types of piezoelectric material, synthetic and natural. So synthetic materials are first quartz, which are stable, next Rochelshad, barium titanate, topaz, silk, tourmaline group minerals, beryllium, langasite, lithium niobate, potassium niobate, sodium tungstate, so etc. So these were some of the piezoelectric materials. So I said quartz is of having stability and Rochelstad characteristics. It is gives high output, and barium titanate, I said we can be formed into any shapes. So one material will be having one characteristics. So all the one material cannot have all the desirable properties. So these were some materials we discussed in piezoelectric materials. Next we saw some of the desirable properties of piezoelectric material. The first property we saw is stability. So it is stable at all conditions, and it gives, second one we saw, high output. So it gives high output. And the third is it is insensitive to temperature conditions. And the next we saw it is insensitive to humidity. And last we saw it has the ability to form into any desired shapes. These were the 5 properties of piezoelectric materials. The next we saw is piezoelectric transducer. So piezoelectric transducer is a one which uses it is a device which uses piezoelectric effect to measure the change in acceleration, force, strain, so on. So with the crystal we were keeping the piezoelectric crystal inside, so force is applied on it, so that force is converted into the voltage. So we saw some of the advantages and disadvantages of piezoelectric transducer. The advantages were, first one, it has high stability. So it has high stable. I said quartz is a stable material. So almost maximum it is a stable at all conditions. The second is it is of small in size. We can easily handle. Third advantages is high frequency response. That means for any sudden change in the input, it will give sudden output. Instant output we are going to get. So it has high frequency response. The next we saw rigid construction. Means it is made strongly, because so even if you handle hardly, it will be able to withstand. The next we saw it is suited for dynamic measurements. So there is a change, pressure variation in the IC engine always. So if you want the result at an instant, pressure will be continuously changing. So in that conditions, piezoelectric are used. It will give instant result. So it is suited for dynamic measurements. So these were some of the advantages of piezoelectric transducers. So let's see, we saw the disadvantages of piezoelectric transducer. The first one was the output is affected by temperature, change in temperature. So if there is any change in the temperature, definitely it would be going to affect the output. So this was one of the disadvantage. And the second one was it cannot be used for static conditions, because in advantage I already said it is suited for dynamic conditions measurements, but it cannot be used for static conditions. And the third disadvantage is the output is quite low. So these were some of the disadvantages of piezoelectric transducer. So we saw some of the sample questions from this session that they might be asked in an examination. So let's go for the test. Okay, are you all ready? I will be giving some multiple choice questions. You need to write down the answer. Are you ready? Yes. Let's go. The first question is, when the materials are applied with mechanical force, a voltage is produced and it is called as, first option, photoelectric effect, second, photovoltaic effect, third, photoemissive effect, and the fourth, piezoelectric effect. Can you guess the answer? Once again I would try to read the question. When a certain materials are applied with mechanical force, a voltage is produced. What we call that effect? Is it a photoelectric? Is it a photovoltaic? Is it a photoemissive? Is it a piezoelectric? The solution for this is option D, piezoelectric effect. Piezoelectric effect is when the materials are applied with a mechanical force, it is a voltage is produced. Okay. I hope you all answered rightly. We'll go to next question. The next question is, when certain materials are applied with voltage, they change their dimensions and is called as option A, photoelectric effect, option B, photovoltaic effect, option C, photoemissive effect, option D, piezoelectric effect. Once again I would like to read the question. When certain materials are applied with voltage, they change their dimensions. We call it as. Can you guess the answer? The solution is piezoelectric effect. We'll go to next question. The common piezoelectric material is, I have said in the class, the commonly used material, piezoelectric material, which is one of them? Is it a quartz? Option B, copper. Option C, iron. Option D, glass. Which material is commonly used? Which piezoelectric material is commonly used? The solution is option A, quartz. Quartz is a commonly used piezoelectric material because of its stability. The next question is, the piezoelectric transducer converts mechanical force into resistance, option A, option B, voltage, option C, capacitance, option D, inductance. What does piezoelectric transducer do? A piezoelectric transducer converts mechanical force into what? Guess the answer, quick. The solution is B, voltage. The piezoelectric transducer converts mechanical force into a voltage. We'll go with the next question. The desirable properties of piezoelectric materials are: number 1, stability, number 2, high output, number 3, insensitive to temperature extremes and humidity, number 4, ability to be formed into any desired shape. Option A, statement 1 is correct, that is, it is stability. Option B, statement 1, 2 is correct, that is stability and high output. Option C, statement 1, 2, 3 is correct, that is stability, high output, insensitivity to temperature, extremes and humidity. Option D, all are correct, that is the properties, it is stability, high output, insensitive to temperature, extremes and humidity, ability to form into any desired shape. Guess the answer. The solution is option D, all are correct. That means the properties are, it is stability, it is high output. Another property is it is insensitive to temperature, extremes and humidity, and it is ability to form into any desired shape. So these all are the properties of the piezoelectric material. So I would like to end this session with a quote from Lynn Pernil. Never stops learning because life never stops teaching. Thank you.